Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. Hi, welcome to this video. We're going to talk about graphing functions. Now, this first video is all about linear equations. Okay, let me write this out. When you are graphing linear equations, you know, the name of it actually gives you a clue. What you do is you look at the first word, line. Okay? We're going to start with the equation y equals x. Very simple looking equation. Now, when we graph y equals x, it's going to look like this. Let me kind of straighten it out here a little bit. Now, theoretically, every line of a graph goes forever through the entire grid. All right, now let's see if I got it lined up correctly. All right. Now, how do I know that that line of that equation is in that area? Well, what we're going to do is we're going to create what's called an XY chart. Okay? And what we're going to do is we're going to create the x values ourselves. So it's always a good idea to start with 0. Now, if we put 0 in there, y equals 0, well, that's pretty easy. If x is 0, y is 0. And then let's try some positive numbers. If x is 1, y is 1. If x is 2, y is 2. In fact, the equation itself tells us that whatever x is, y is going to be the same thing. Okay, now I know this is a very simple equation. Seems like a waste of time, but I want you to notice the process here. So I take a look, if I don't know just from previous experience what a graph looks like from that equation, make an XY chart. You pick the x values and then we calculate the y values. So let's go ahead and look at -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, and so on. Obviously, all we need is 2 points, but if we have 3 or more, we can make sure everything's lined up, and then we connect the dots. There we go. Every point on that blue line, including these green dots, solve that equation. Now that's called the parent function. Okay? Any linear equation starts off in that form. Now we're going to change the parent function, y equals x, to something a little bit different. I have some examples for you. And the question is, if we're going to take y equals x and do something to that x on the right side, in this case add or maybe subtract a number, what happens to that line? So let's go ahead and do it. Let's choose some values. -2, -1, 0, +1, +2. All right, if x is -2, if you add 1 to it, that gives you -1. If you have -1 and you add 1 to it, that gets you back to 0. If you have 0 and add 1, that will give you 1 for the y value. And of course, this 1 turns the y into 2, and the 2 turns it into 3. Obviously, you're going to see a pattern. All right? Now let's go ahead and graph that. So we look at our XY chart. If x is -2, y is -1. When x is -1, y is 0. 0, 1, 1, 2, 2, 3. Now let's go ahead and connect the dots. Remember what the parent function y equals x looked like. Okay, now let's go ahead and choose a different color. Say red. And now let's add 2. Okay, I'm going to go ahead and work with this equation. Y equals x plus 2. So -2 plus 2 is 0. -1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. And 2 plus 2 is 4. Okay, now let's go ahead and dot those. -2, 0. -1, 1, 0, 2, 1, 3, and 2, 4. Let's graph it. Now you can see how the red graph line is different from the green and still different from the original parent function. Now let's go ahead and look at this last equation. I'll do it in orange. Y equals x minus 3. Notice now we are subtracting. Okay, so negative 2 take away 3 is negative 5. Negative 1 take away 3 is negative 4. And then negative 3, negative 2, negative 1. All right, let's take a look at that. Negative 2, negative 5. Negative 1, negative 4. 0, negative 3. 1, negative 2. 2, negative 1. Obviously, you see a pattern. So finally, for these equation sets, notice what happens to the number, or when the number after the x is changed. If it's positive, these lines go up, and it connects with the y-axis at positive 1, and then later at positive 2. But in the last one, the y-intercept is negative 3. So that indicates that the number after the x being added, in some cases subtracted, is the y-intercept. All right, now let's take a look at how to change the angle of the line. So again, our parent function, the very starting point is y equals x, and we graphed that on the very first page of this video, and it looks like this. Okay, now we're going to manipulate it a little bit and see what happens. What if we multiply it by 2? What if we multiply it by 3? What if we multiply it by a negative number? And finally, what if we multiply it by a fraction? If x is negative 3, 2 times negative 3 is negative 6. Negative 2 times 2 is negative 4. Negative 1 times 2 is negative 2. See a pattern? 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. All right, let's graph that. Negative 3, negative 6. Negative 2, negative 4. Negative 1, negative 2. 0, 0. 1, positive 2. 2, 4. And 3, 6. All right, let's look at this next variation. What if we multiply our x by 3? Okay, now our values are going to change for the y when we calculate it. So let's see, we're going to multiply everything by 3. So negative 9, negative 6, negative 3, 0 again, 3, positive 6, positive 9. All right, let's graph it. Next example, and I think you can see what's happening here, y equals negative 4x. We're going to multiply everything by a negative 4. Obviously, the angle of the lines keep changing, but how do we know how it's changing? Well, we're going to multiply all the x values by negative 4. So, positive 12, notice the sign change, positive 8, positive 4, 0. Can you finish the pattern? Negative 4, negative 8, negative 12. Let's graph it. So let's look at what we've got. In the graph y equals 2x, that's the blue one, notice what happens when the graph was multiplied by 2. I see a little pattern here. Over 1, up 2. That's the slope. That's the angle of the line. Okay, y equals 3x. Let's do it right here. Notice that from one part of the graph to the other, it went up 1, over 1, up 3. That's the slope of that line. Negative 4. Whoops, I had to do a quick switch there. I did my green graph wrong. I have to flip it around because I noticed that it's being multiplied by a -4. And notice that, let's look at this part here. It goes down 1, 2, 3, 4, and over 1. So just pointed the opposite direction. So the question is, what about this one? Well, whatever gets multiplied by the x is the slope. Okay, so if it's 2/3, that means that it must go up and down and over 3 through the origin part. So let's go ahead and go over 3, 1, 2, 3, and up 2. Let's go over 3 and up 2. Over 3 and up 2. And we can keep doing that forever. Notice the angle of the dots. It will go through the origin. Now I'm going to go over 3 and down 2. Over 3 and down 2. Over 3 and down 2, and so on. Let's go ahead and put a graph on this. So the multiplier number is the indication of the slope. That's the angle of the line, positive or negative. Now let's summarize what we've got so far. Equations in this form are called linear equations in slope-intercept form. So y equals mx plus b is the usual way that we think of it, and the plus b part is the y-intercept. So that tells you right away where the graph of the line intercepts the y-axis. Okay, it's the y-intercept. So you know right where that line cuts through, and you would start and dot that location. The other part is the m, and that's known as the slope. So that's the angle of the line. All right, let's kind of show a very quick example and we'll be done. So for this equation, y equals 1/4 x minus 3. Notice that the b part is actually a -3. We need to think of it as adding a -3. So we start by marking that on the graph. On the y-axis, remember the vertical one, we go down 3. That's the -3 intercept. Then we look at the slope from the y-intercept, not the origin, but from my blue dot. I'm going to go over 4 and up 1, but I have to do it in the right direction. Positive slopes have to slope upward, so if I go to the right 4, I'm going to go up 1. Now let's do that again. Over to the right 4 and up 1. Now if I go the other direction, I go over 4 and down 1. Otherwise, I would not have a connected line. Let's graph it. So you can see that this equation, y equals 1/4 x plus -3, has a -3 y-intercept and a slope of positive 1/4. Check out my other videos that will show you more about slope-intercept form and how to predict the graph. Thanks for watching. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard and take care.